Bienvenidos, Ushamdid, and welcome to this Hut 8 networking techtorial on Cisco's Enterprise Networking Security and Automation, or ENSA, version 7 course. In this packet tracer tutorial, we're going to be taking a look at activity 12.5.13, where we're going to be troubleshooting an enterprise network. And this is one of my favorite activities of the ENSA course because it asks us to bring all of the knowledge that we've acquired to this point in the course into play. And we now get to apply that knowledge. So here's the network that we're going to be working with. And as you can see over here on the right-hand side, it's kind of fitting that all these lights are blinking so quickly. We are in the holiday season, but in a network, you typically might think that there could be something going on there, right? I mean, take a look at how these lights are just blinking uncontrollably here and extremely fast. So let's go ahead and dive in. We're going to skip over the scenario. We're just going to be using everything we've learned in the class in order to try to complete some of the information in the addressing table, as well as address some of the problems. So we'll start here with part 1. It says verify switching technologies. So port security is configured to allow PC1 to access switch 1's fast Ethernet 03 interface. All violations should disable the interface. So let's get on to switch 1 and let's see how we're configured here. And let's give ourselves a little room with which to work, and we'll jump onto the CLI. So it wants us to say show port security. Now if I do a question mark here, you can see that we might be able to add a few additional options in, but let's go with show port security. And you can see that nothing shows up. What if I was to say show port security interface and then fast Ethernet 03? And so if we take a look here, by narrowing it down to the interface, we're going to pick up some additional information here. In fact, some much needed information. We're going to see that port security is actually disabled. Now, the port status says secure down, but again, port security is disabled. The violation mode is shut down. This is the default violation mode. There is no aging time configured. In other words, if this port were to experience a violation and get shut down, it would not be brought back online auto-magically. And that kind of dovetails into your CCNP EN core studies, where you're going to learn about air disabling of the ports and how to bring those back online after a certain amount of time. You can see maximum number of MAC addresses. Again, this is the default 1. So if I was to say nothing other than switch port security, and maybe the command that they're showing here to the right-hand side of our screen, which is switch port security MAC address sticky, by default, we will be in the shutdown violation mode, and only one MAC address is going to be allowed. So let's go ahead and make that happen. Let's go into global config, or from global config, we're going to go into interface configuration mode, and let's jump into interface fast Ethernet 03. Now, here's what's interesting. I'm going to go ahead and say switch port security, MAC address sticky. And what this means is that this port right here, this fast Ethernet 03 port, is auto-magically going to learn the MAC address because it's looking at the source address field in the layer 2 header coming in from PC1 here. Now, I'm doing this intentionally. I didn't say switch port security intentionally for a reason. Because what if I now say do show port security interface fast Ethernet 03? Well, it's interesting, right? You can see here it still shows it's disabled. And that's because, and this is one of the things overlooked by learners that are new to port security, is where it says switch port security, that's actually what activates port security. If you don't have that command there, I can say switch port security MAC address sticky. I could say switch port security maximum 55 for 55 MAC addresses. I could say switch port security violation mode, restrict. And none of those settings are going to take effect until I say switch port security all by itself. So let's go ahead and add that in. Switch port security. Let's rerun that command and now take a look. Port security is enabled. In fact, we got 8 percentage points over there in the bottom right-hand corner. Very hard to see, very small, but it gave us 8%. And so you can see port security has been enabled. The status is no longer secured down. Remember up here? It was secured down. Now it's secure up. The violation mode is shut down. That's the default violation mode. And I want you to watch this. Let me say do show run. And let's take a look at Fast Ethernet 03. And there it is. Switch port access VLAN 10, switch port mode access. So we've got an access port. And we've got switch port security and MAC address sticky. Now you'll notice that it's not showing me the MAC address. It doesn't show me the MAC address that should be sticking to it. It doesn't show it there, and it doesn't show it here. And my question to you is, why? Why might there not be a MAC address here yet? And remember what I had said previously, and that is that traffic coming into Fast Ethernet 03 from PC1, switch 1 is going to be looking at the source MAC address field in the layer 2 header. And so if you said, well, there hasn't been any traffic sent to switch 1 from PC1 yet, you would be absolutely right. And it's because we haven't initiated any traffic here, right? I haven't run a ping command or a traceroute command or a SSH or telnet, whatever the case may be. We haven't initiated any traffic from PC1 to anywhere on the network. So again, we have to have some traffic. So let's go ahead and make that happen. Even if that traffic doesn't get to where it's supposed to go, because we've got a lot of things broken right now. So let me get to PC1 and let's try to ping our outside host out here. So we're going to go for broke right out of the gate. I'm going to see, can I ping 64.100.100.10? Now, remember, even if the traffic doesn't make it here, as long as it makes it to the port right there, Fast Ethernet 03 on switch 1, we should have a MAC address that would get populated, and there we go. You can see the request is going to time out across the board. So now let's take a look at do show run, and we'll come down here to Fast Ethernet 03. We don't have anything there, but what about show switch port security? We still don't have anything. And so this could be a little packet tracer snafu. Let me do this. Let's come back here, and we're going to come to gig 001 on router 1. So we're going to run a ping to something we should be able to hit, and that is 192.168.10.1. And let's see if we're able to ping through there at all. And it looks like this may be broke as well, and this is getting interesting. All right, so these things may be, we may have some issues over here, it looks like. And let me take a look. Let's take a look at our, not our config, I'm sorry. We're going to take a look at our desktop here. And let's take a look at this configuration. Ah, so we've got DHCP. Okay, so it should be DHCP. All right, so again, fortuitous failure, right? I am thinking that PC1 probably has an IP address on it, but it doesn't. You can see we've got sort of this bogus address here. So if I was to briefly, let me cheat here a little bit, say 192.168.10.10, and then we'll do that in the default gateway, 192.168.10.1. Sorry, not config there. Let's come back to the desktop, and now let's see if I can run, if we can run the ping command here and get to 10.1, if that is going to work. And there, again, could be something wrong here on the router. And all I'm trying to do is to generate some traffic that's going to hit this switch so that when we take a look at the port, and there we go. All right, so we needed to change it from that APIPA 169.254, the failed DHCP address that you receive, right? And those are referred to as APIPA. They're automatically allocated when DHCP times out and cannot get you an address. So we clearly know we've probably got some DHCP concerns here on router 1, but this is what I wanted to show you. That is the sticky, right? It learns that address. If I come down here and we say do show run, and now we roll down, you can see that we end up with this new line here in the config that should be maintained across a reboot that has learned the MAC address of PCA. How could we confirm that? What if I was to do a Control-C here and say ipconfig, /all, and we should see, and let's give ourselves a little more space here, we should see the physical address, the MAC address, ends in Alpha Baker 7 Delta. What about switch 1's output here? Alpha Baker 7 Delta. And actually you can kind of see across that is, pull it over here a little bit more, you can see quad 0 or 00002.1787. That is the MAC address, right? So that is what port security is all about. The next thing I want to show you here is what if I was to say switch port security maximum 1, and then switch port security violation mode shutdown. So I've just added these two configuration stanzas to the overall switch config. But let me say in and write mem. But what happens when I say, not show run, show run, and let's take a look at Fast Ethernet 03. How come those two commands that I just ran and applied to this port, switch port security maximum 1, and switch port security violation shutdown, they don't show up here? Yeah, remember, those are the defaults, and Cisco's notorious for things like this. So questions that you might count on seeing is you're shown output like this and asked, what is the maximum number of MAC addresses? Because you have to know the default, which is 1. And you may be asked a question, what is going to happen if a violation occurs? It would be the shutdown mode, where the port would become air disabled and shut down. So that is the switch port security piece of what we were doing right here. So devices in the LAN on switch 1 should be in VLAN 10. And they are in VLAN 10, as we can see here. And let's go ahead and let's take this a step further. Again, not required for this activity, but definitely something you want to consider. If I go into interface Fast Ethernet 03, I would also want to have spanning tree port fast, because it's a host-facing port. And I would also want to have spanning tree BPDU guard on, and even spanning tree guard root. And again, you may think, well, wait a second, if you got BPDU guard on there, why do you need guard root? Remember, guard root is protecting from a superior BPDU showing up that could try to take over the root bridge status. But BPDU guard is going to air disable, shut the port down if it gets a BPDU. Again, defense in depth, right? Defense in depth. Even though BPDU guard is going to shut the port down on the reception of a BPDU, and I shouldn't say shut down, it's going to air disable it and stop passing traffic on it. Guard root, we should have that on there as well, just in case. So let's go ahead and type in, and we'll say write mem, and let's say show run. And again, we're not losing any points there. We're just beefing up that configuration, and that is a really nice looking host-facing switch port configuration. All right, so PC1 should be receiving an IP address from router 1. Well, we saw that that wasn't happening, and we learned the hard way that that was not what was happening. Does the PC currently have an IP address assigned? Notice the gig 01 interface on router 1 is not in the same VLAN as the PC. Now, that is a little typo right there because it should be gig 001. That's the interface they're referring to here. So we've got a few problems. So the first thing that we're going to do is we're going to come back to the PC here. We're going to close this down, and we're going to take this guy back to the way it should be configured, which is DHCP. And we'll allow it to time out here in a couple seconds. You should see another APIPA 169.254 address of some kind that's going to indicate that DHCP is simply not able to allocate an address. And there you go. You can see DHCP failed. A PIPA is being used. We get the 169.254. So if we come up here, and I guess let's take this all the way to the top here. So does the PC currently have an IP address assigned? No, we know that it does not. So here's the thing. These connections here, right? We notice that the switch for the PC connection has it in VLAN 10, but let's mouse over here and let's see. So they may be referring to the gig 01 on the switch, but here it says, notice the gig 01 interface on router 1 is not in the same VLAN. So I think that's a typo there, not a big deal. We know that it's gig 01, so let's go ahead and continue here down and take a look. We've got interface gig 01, switch port mode access, but it's not in the right VLAN. So let's get into Gigabit Ethernet 01, and let's do some other things here as well. Let's go ahead and say switch port mode access VLAN 10. Switch port mode access we've already got. We'll say switch port access VLAN 10, and now it is in the right VLAN. Now, this is a router-facing port here, right? It's not connected to another switch, so we're not going to be receiving BPDUs. We want that port to come up right away, so let's say spanning tree port fast, so we don't have to wait for the listening state and then the learning state and then maybe max age timer considerations, right? So we want to skip all of that, and we want it to transition, that port to transition to the forwarding state immediately. Let's also say, let's also say spanning tree, BPU Guard enable, right? Because is the router sending BPDUs? And the answer is no. The router should not be sending BPDUs in this configuration. So we'll put BPDU Guard on there because we don't want somebody to unplug the cable from the switch and then insert a switch. And I can also say spanning tree guard root, right? So now let's go ahead and say do show run. Let's take a look at what we've got here. And that is a much better, much nicer looking configuration for that port. And you can see we picked up a few points along the way, but now that the connection is there and we're all in the same VLAN, the PC and the router that is, we take a look at the PC and let's see, well, let's click over to static and let's force a DHCP discover request. And again, if you DHCP, remember it's DORA, discover, offer, and I'm looking at the IP here. Yeah, request and proposal. And 192.168.10.10. All right, so everything looks good here. We've got all the default information. How can we check this? Well, let's go ahead now and let's try to ping our default gateway. And there we go. And so now the default gateway is working. We're able to reach it, and the PC is configured. And so we'll come back to this PC here shortly. And so we went ahead, and you can see they actually even asked to put port fast on there. So reset the interface on the PC from the GUI. We did that, or you could have gone to the command prompt and said ipconfig renew. But we've got the information in there that we wanted to have entered in there, and the LAN connected to router 3. So now we're going to transition over here. And as you can see, this LAN is going crazy right now. So it's probably something, there's probably something going on over here that we definitely need to investigate. So had an additional switch added to the topology, link aggregation using EtherChannel is configured on switch 2, switch 3, and switch 4. Right, so we're going to have to take a look at these different EtherChannel configs, and again, we're going to have to sort out which interfaces are which for channel group 1, 2, and 3. The EtherChannel links should be set to form a channel without using a negotiation protocol. All right, issue the command on each of the switches. And so in other words, if it's not using a protocol, it's not using PAGP, the port aggregation protocol, and it's not using LACP, the link aggregation control protocol. It means it's just simply using EtherChannel and what I like to refer to as mode on. That's all that's going on. So let's jump on to switch 2 here. And we'll give ourselves a little bit of room. We'll come to the CLI, and we'll go into privilege exec, and we'll say show EtherChannel summary. And you can see here that it's showing for port channel 1 and port channel 2 that they are both configured. The ports are bundled. And you can see right there in EtherChannel, and it's up. So from switch 2's perspective, everything looks okay. Now, what we might want to do is we may want to say show run, and excuse me. And you can see there's port channel 1, there's port channel 2. They've got the native VLAN switch port mode trunk. Maybe we put a switch port no negotiate on there. But you can see here the mode for fast Ethernet 01 and 02. And so let me mouse over fast Ethernet 01 and fast Ethernet 02 between switch 2 and switch 3. And so we take a look here, and they're definitely channel group 1, mode on, and so everything looks good there, right? Let's take a look at switch 3 now, because switch 3 is connected directly to switch 2, and so switch 3 should have similar output. However, it's possible that that is not the case. So we'll say show EtherChannel summary, and you can see port channel 1 is down, and that's what the D means right here. The S is layer 2, right? You can see it's a layer 2, and I think of it as switch for layer 2. Port channel, and it's D, it's down, right? And you can see we have no ports that are in that port channel. So what do we need to do here? Well, let's take a look at fast Ethernet 01 and 02, see what kind of a config we have in there. And there is the interface, right? That logical port channel interface, which has the switch port trunk native VLAN 99 and switch port mode trunk there. But when we look at fast Ethernet 01 and 02, what are they missing? Exactly. They're missing the EtherChannel commands that are going to be required here. So let's get into global config. I'm going to say interface range fast Ethernet 01 to 02. So I'm pulling 2 of the ports in at the same time so that I only have to run the command one time. And that's going to be channel group 1 mode on. All right, and you can see the port channel has changed the state to up. So let's go ahead and say show EtherChannel summary. And now you can see that the port channel is up, and it looks like the Christmas tree blinking, the frantic blinking that was taking place over here has stopped, right? And we're blocking, right? We're blocking these 2 ports, or I'm sorry, the EtherChannel right there. So let's go ahead and say show interface trunk. And we should see that, and there it is right there, port channel 1 and port channel 3. The trunking mode is on. 802.1q encapsulation, which today is your default. And ISL is not even an option anymore on newer switches. And our native VLAN is 99. And most importantly, VLANs in the spanning tree state and not pruned. In other words, the VLANs that we are forwarding across that trunk, 99, 50, 40, 30, 11, and 1. All right, so were there any issues with trunking? Not there, and as you can see, everything is still green here, right? So we don't have anything blocking, so we may have to take a look at some other things. It says verify the trunk status on all switches. All right, so we're going to do this on all switches. So show interface trunk, and let's see here. And we've got this here, and that is going to be this link right here. So it looks like we're doing router on a stick right there. But you can see that VLAN 11 is not being forwarded here, right? It doesn't look like VLAN 11 is being forwarded, where on switch 3, it's listing VLAN 11. And take a look at port channel 1. None, right? So no VLANs are being forwarded across that port channel. So that might be a problem, because here we are forwarding across both of those. And so the show interface trunk, you can see port channel 1 and port channel 2 both have the same native VLAN of 99. However, we've got this extraneous VLAN here, and it looks like they're asking to have the native changed on the router on a stick port. And so we'll go ahead and we'll make that change. We'll get into global config, and we'll go into interface gigabit Ethernet 01, because that, interface gigabit Ethernet 01, because that is our switch port trunk native VLAN 99. That is the native VLAN. In other words, if it's not tagged, when it goes across that trunk port, that is what it would be tagged, the VLAN it would be tagged with. So spanning tree should be set to PVST plus on switches 2, 3, and 4. Now let's go ahead and check that out. Let's go ahead and say show spanning tree. And we take a look back up here. So we say show spanning tree, and you can see that right there tells me that we are using PVST plus because the mode is IEEE. If we were using rapid per VLAN spanning tree, it would not say IEEE. It would say RSTP. And in fact, if I was to say spanning tree VLANs 1 to 4094, spanning tree mode, and we did rapid, and then I said do show spanning tree. Sorry, let's pull this back here. I thought it would be in the do show spanning tree. You can see it shows RSTP. However, they're asking for PVST to be made the mode. So we're going to say spanning tree mode, and the two choices we have here are PVST, which again for Cisco will be PVST plus. And remember that PVST plus, that plus sign is indicating that we're using 802.1q trunks. All right, so spanning tree mode, PVST, and then let's come up here to switch number 3, and we'll say show spanning tree, and you can see it looks like we're set here, and so we can simply say spanning tree, get into global config, and we'll say spanning tree mode PVST. And then finally down here on switch number 4, and we'll bring switch number 4 into the fold. We'll go to the CLI, and we'll go into global config and say spanning tree mode PVST. All right, so we've made the change across the board. On switch 2, they'd like us to take a look here at show, or let's say do show. We'll pull out of the config mode there. So show spanning tree summary totals. And this is another way to see that the switch is in PVST mode. Now, it's not going to say plus here, right? But that, because we're using 802.1 encapsulation on the trunks, it is PVST plus. And so this is another way to see the mode that you're in. All right, the command output shows that switch 2 is not the root bridge for any VLANs. We're going to correct the spanning tree status. So we want switch 2 to be the root bridge. And they're asking to do the root primary command. Now, this is a macro command, right? And what that means is when I run this command and I say spanning tree VLAN 1 to 1005, right? So the regular range, not the extended range of VLANs, root primary. This is going to set the priority to 25. I can never remember off the top of my head. It's 25, and we'll see here in just a second. Let me give it a second here. It looks like the Mac is thinking. All right, there we go. And so if I was to say do show spanning tree, 24, we'll come back up here, 24576 is what it sets the priority value to, and that's what the macro is doing. So you'll notice I never said set it to 24576. It did it auto-magically, right? So now check the spanning tree status again. So let's run that command, that do show, pull this back here. I think it had it in the history. So we'll say do show spanning tree summary totals. Oops, sorry about that. Come back here. Do show spanning tree summary totals. And you can see that the switch is in PVST mode. That's what we wanted. And then we've got the root bridge output right below that. I'm sorry, I was looking down here at some of the other information to see if there's anything of note, and there's not. So you can see here, root bridge 4 default VLAN 30, VLAN 40, VLAN 50, and the native VLAN. So this switch, and if you were to say do show spanning tree, it's going to show you the same thing when it's going to say this bridge is the root. And here it is right here for VLAN 1. This bridge, where are we at? Sorry, it's going by too quick. And there you go. You see this bridge is the root. So that's what it's going to say for these VLANs, for which it is the root bridge. And then again, you can see this bridge is root. So you could see it saying do show spanning tree, or that command that they provide here, the show spanning tree summary totals, which might be a little more consolidated, a little more concise, easier to look at by simply, by simply taking a look right there. All right, so everything looks good. We've got 48% right now, so we're cruising along. Now, part 2, verify DHCP1. So router 1 is the DHCP server for R1 LAN. R3 is the DHCP server for the 3 LANs connected over here, 30, 40, and 50. Check the addressing of the PCs. Well, we know that PC1 is okay because we've already configured that. So if I was to come back in here, let's check PC2. Let's do these guys in order. I'll bring it over here and we'll provide ourselves a little more room. We'll come to the desktop. Let's take a look at the config. So PC2 should be in the 192.168.30, and it is. And a quick way for us to check is, can we ping that default gateway? So let's go ahead and say ping 192.168.30.1. And everything looks good there for PC2. Let's check PC3. And you can count on something not being correct over here. We got to figure out what that is. And take a look at the IP address for PC3, 192.168.40.16. And that's the subnet it should be in. But take a look at our default gateway setting here, 192.168.30.1. Now, if it wasn't a /24, this could actually be a legitimate default gateway value. If we had something like a /16, that could be a legitimate value. But we know, because it's a 24, this IP address, right, that is not in the same subnet as the 192.168.40. In fact, it's in the subnet for PC2, which we just saw. So the correct addressing is not configured here through DHCP for PC3. Let's take a look at PC4, and let's see. The IP address for PC3 was correct, but not the default gateway address. So let's come over here. You can see 50.18, and then take a look. The default gateway address, again, looks like we've got an issue with the DHCP config on router 3. So IP addresses are correct. Default gateway addresses are incorrect. So let's come over to router 3, because clearly we've got some investigation to do here, indicating that DHCP might not be configured correctly. And then we'll say begin DHCP. And we'll scroll back just a little bit here. So here are the DHCP configuration stanzas. We're excluding first 10 addresses here. And then we've got, or I should say 1, 2, 3, 4, 5, 6, 7, 8, 9, first 9 addresses. Sorry about that. And then we've got the DHCP pools. And this is where we're going to focus here, right? So IP DHCP pool LAN 30, right? The network looks correct and the default router looks correct. So for VLAN 30, everything looks good. If we take a look at VLAN 40, what is wrong here? And VLAN 50, what is wrong? So there are some issues here. They're DHCP issues. So let's get into global config. And the issue for these pools is the default router setting for the 2 pools is wrong. So we've got LAN 40 and LAN 50. So IP DHCP pool LAN 40, the default router should be 192.168.40.1. And then for IP DHCP pool LAN 50, the default router should be 192.168.50.1. So let's do end. We'll say write mem. Let's do a show run and begin DHCP. And now let's take a look and see what we've got here. So you don't have to say no default router. I can just simply put in the new default router value. So I don't have to remove the old value and then put the new value in. I simply put in the new default router value. So these look much better. Now, the test is going to be coming to the PC, and you can see it's still mismatched. So I'm going to click on static, and I could have said ipconfig renew, but we're not going to do that. I'm just going to go ahead and come into the GUI and click on it here. And you can see now we have the correct DHCP value. In fact, the final check is, can you ping that default gateway 168.40.1? And we can. If I come over to PC4, still no update, but let's go ahead and we'll renew the DHCP config, and much better, right? Much nicer. We've got the correct default gateway value in here. Let's come over here and let's say ping 192.168.50.1. All right, so those are taken care of. You can see our percentage now is up to 63. So we're making really, really good progress. Now, it says, were you able to ping all IPv4 addresses? So we were, in terms of the default gateway. So now we're going to verify routing, right? We're getting into the layer 3 world here, moving away from some of the layer 2 tasks that we were working on. So it wants us to verify the following requirements have been met. If not, complete the configuration. So all routers are configured with OSPF process ID 1. No routing updates should be sent across interfaces that do not have routers connected. So let's bring up router 1 here. And now we're going to take up some additional space because we're focusing in on the routers here. So I'm on router 1, and let's go ahead and say show run, and we can take a quick look at that OSPF config. So here we go. Router OSPF 1. So on router 1, the process ID is correct. Now, am I passiving? Do I have a passive interface on gig 001? I do. Passive interface on gig 001. So that requirement is met. And so that was just the first requirement. So now let's take a look at router 2, because they make a comment here about router 2, and we want to see what that might have to do with. So let's go ahead and say show run, and we'll come down to the OSPF config. So the process ID is correct. Remember, the process IDs do not have to match. They do not have to match. But do you see a passive interface command in here on router 2? So there's no router this way, and we would not, and this interface right here, the gig 00 interface, is not configured anyway. They had an activity a long time ago where they were connected to an ISP, and for whatever reason, they had the passive interface command on that connection, but there was no network statement that accompanied it. And it was always odd that they had done that, but here you can see there is no network statement for that interface gig 00 right here. But gig 01 should be passive. So we'll get into router OSPF 1, and we'll say passive interface gigabit 01, and we should probably get a couple points for that. We do not, but that's okay. So passive interface gigabit Ethernet 01, but what is it? Let me actually read. R2 is configured with an IPv4 default route pointing to the ISP and redistributes the default route into the OSPF2 domain. Okay, so that's another problem that we see here, right? So not only is the interface not passive, there is no default information originate command here. So it might have this default route configured, pointing to gig 00, sending traffic out of the enterprise to the internet. However, we're missing the default information originate command. Now, there's an always keyword here on the real iOS. If you want it to originate that default route, irrespective of whether you have access to that default route, whether it's configured, right? You could put always here at the end. But right now, we just want to originate it. And that if that default route went away, we would stop advertising it or originating it into OSPF. And so now let's go ahead and say do show run and take a look at the configuration as it stands right now. So there's our default information originate, and there's my passive interface gigabit Ethernet 01. Now I am tempted to run the passive interface command on gig 00, or to apply it just to see if it results in points. So passive interface gigabit Ethernet 00. Let's see, we've got 68%. Yeah, and I didn't think we would get points for that, but I'm just checking, right? A little skeptical here with packet tracer sometimes. So we'll take that command off. We'll say do show run. Take another look here. And you can see that we have everything that we would need. Now, we've got some network statements here, and I haven't validated these, but we've got 2/30s, and those are our serial connections. And then we've got the 192.168.20, which is our LAN connection, out gig 01. Let me check something real quick. Do show IP interface brief. Excuse me. Okay, good. Yeah, I'm just checking. Like I said, I was concerned that we didn't get any points for that passive interface command on the gig 01 interface, but we'll see how this plays out. So R2 is configured with a default IPv6 fully qualified default route pointing to the ISP, and it redistributes it into OSPF. And so let's go ahead and say do show run, and let's see, we'll take a look at both of these configs here. IPv6 router OSPF1. So again, you'll notice no default information originate here in the IPv6, excuse me, the IPv6 config, and no passive interface here in this IPv6 config. So let's take care of that. IPv6 router OSPF1, I should have passive interface gig 01, and maybe this is why it was holding the points back. So we're at 68 now, and no, we're still at the same default information originate. We'll get some points for this, I'm assuming. We do, and we're up to 74. So the two passive interface commands in both the IPv4 OSPF config and the IPv6 OSPF config did not result in any points being awarded. However, that was what it was asking for. All right, so we took care of the IPv4, we took care of the IPv6, NAT is configured on router 2, and no untranslated addresses are permitted to cross the internet. And so what they're saying there is we should have ACLs in place so that only NATed addresses make their way out across the internet. So let's check the routing, or actually, I'm sorry, let's come down to router 3 here real briefly. And let's pull this up just a skosh. And let's say show run. Before we get into the NAT, we'll take a look at the OSPF config here. And we can see, and you know what? I need to go back to router 1 real briefly, and let's say show run. I want to make sure there's no IPv6 config. I didn't remember seeing an IPv6 OSPF config on router 1, and there is not. And so that's interesting, and I don't think they ask you to recreate that OSPF config. They do not. So I guess there's just no IPv6 OSPF configuration on router 1. And again, I'm coming back to see if there was a passive interface that needed to be applied. So now over to router 3, which does have both an IPv6 OSPF config and an IPv4 OSPF configuration. And you can see in here, there are no passive interface commands in here. And you know what I'm wondering? Let me check this real quick. On the passive interface thing has me concerned. So let me go into global config. Let's go into router OSPF1. And let's take a look at that config in OSPF. And I'm going to say no passive interface gigabit Ethernet gigabit Ethernet 001. I'm going to say passive interface default. And then no passive interface serial 010 and no passive interface gig 000. And that's going to bring back, and again, I'm just checking to see if that might be what they were looking for when they were asking us to passive the interface. This is to say default, no passive interface default, and then unpassive the two interfaces that we would need, those serial connections to the other routers. But it doesn't look like that's it. And that may be why, that's also why we might not be getting points for the passive interface, is because it doesn't tell the learner how to apply the passive interface. So let's come back over here. And we'll say show run here down to the OSPF config. Let's get into global config. And you can see that on the OSPF configuration, do show IP interface brief. We've got a number of interfaces that don't face routers. So interface gigabit Ethernet 01.30. Oops, sorry. I did not want to do that. Gigabit, let's go into interface gigabit Ethernet 01.30. And we'll say, yeah, I want to say, well, let's do this. We'll say router OSPF1. And I'm going to say passive interface. And this is where you would say passive interface default, right? And then no passive interface gig 010. This way, I'm only running 2 no passive interface commands, gig 020. Whoops, sorry, gig 020. And there we go. And that's going to bring back our adjacencies with these other routers, right? And we did receive some points for that work by passiving those interfaces. So this is saying check and make sure that the static default route shows up. Do show IP route. There we go. Gateway of last resort. And you can see it's an OE2 type 5 LSA external. And then on router 3, and we should see that same thing on router 3, do show IP route. And there we go. Type 5 OE2 LSA, type 5 LSA. And show IP route OSPF on those routers work great. And do all of networks appear on all of the routers? And I think we're good here. We'll see if we're not. But then, so ping the outside host from router 2. So let's see if I can ping the outside host from router 2. So let's do a write mem here. And let's say ping 64.100.100.10. And can this router 2 ping the outside host? And I can, right? So fantastic. All right, correct the default route propagation. We actually did that earlier on. We checked the routing tables, test IPv6 connectivity from router 2 to the outside host. And this is going to be, oops, sorry, didn't want to do that. And this is going to be interesting here. We'll see if the ping 2001:db8 Baker 64 10, and we've got connectivity there. All right, so everything worked great. So test IPv6 connectivity from router 2 to PC4. All right, from router 2 to PC4. So 2001:db8b 50 10. All right, and that works great. And that default route, we already did that. So we're good there. Now, verify Wan Technologies. We've got 20 percentage points that are still hanging out there. So the serial link between router 1 and router 2, which is here, is used as a backup link in case of failure and should only carry traffic if the fiber link, this guy here, or one of these two. So I'm sorry, I assume these were serial links. So we've got 2 fiber links. I just noticed that. I see that they're red, and I immediately assume they're serial links, but they're not. These are fiber links over here. So the serial link is going to be a backup. The Ethernet link between R2 and R3 is a fiber connection. Ethernet link between R1 and R3 is a fiber connection. It should be used to forward traffic to router 1. So the Ethernet link between router 1 and router 3. So traffic should flow. What we're being told is traffic needs to flow, and we'll stick with green, in this direction here is what I'm reading. Excuse me. Ethernet link between R1 and R3 is a fiber connection. It should be used to forward traffic from R1. So let's do what we should do right out of the gate is a trace route, and we can do that using our PC here. And first, let's check and see, can I ping 64.100.100.10? So I'm checking to see, can I get to the outside host from PC1? Because if I can, and let's see what's happening here. There's probably some NAT work that needs to be done. So that is not the direct. Oh, I'm sorry. That's probably why they want us to go over to a PC here. So let me do that. Instead of going for the home run, let's say ping 192.168.20.254. And so can I ping over to that host on VLAN 20? So we had some ARP action, and there we go. It works great. So now let's go ahead, and I can actually trace route from here over to the 192.168.20.254. And you can see that the trace route works. And I go from the PC to 192.168.10.1. We know that that's the router 1 gig 001 interface right here. But then I take 10.1.1.2. So I go up here to router 2. And then I go to 192.168.20.254, which is the default gateway here on router 3. If I say do show IP interface brief, it is not the default gateway, the 254. Where does that sit? Is that actually the PC2 address? Where does that address sit? That is not the address. What are we pinging there? Take a close look on the roundtable R1. Are any of the routes using the serial link? Use the trace route command to verify your system. Oh, I'm sorry. Well, yeah, I was tracing from PC1, so that should be good. In the 254, I don't see 20.250. Oh, I'm sorry. It's the TFTP server. I apologize. I was thinking it was one of these PCs down here. It's the TFTP server up here. So we're coming to router 1 and going to router 2 and coming this way. So currently the flow of traffic is we go here, here, and then over to here. But this is supposed to be the backup link. I apologize there. So the serial link should be the backup link. So we are trace routing out. We are taking the correct hops up here to router 2 and then over to the TFTP server. But what we're learning is the traffic is being sent out the serial 010 interface from router 1 as opposed to the gig link. So now we're going to do some layer 3 traffic engineering. How can we do that? Well, we can make the serial link, which is the default path we're currently taking, right? That's how we're currently traversing to get to the TFTP server. We could make it look worse from a router 2 perspective and advertise out a higher cost to router 1, or we could make that cost look better coming from router 3. So there's a couple ways that we could approach it. The way that they're going to approach it is we're going to drop the cost from or between router 1 and router 3. And the simple way to do that is how they show here. We'll go into global config interface gig 000. IP OSPF cost is going to be 648. Now, that is going this direction, right? That's advertising over here to router 3. We need router 3 to also advertise a better cost. And we'll go into int gig 010 IP OSPF cost 648. And so now the cost should look better taking the lower path. And you can see here, we shouldn't go to 10.1.1.2. We should go to 10.3.3 and whatever router 3 is on that path. Oh, I'm sorry. They've got no IP. So there is a cost command on here already is what it looks like. Okay, so it looks like the cost was already on there. So I want to say no IP OSPF cost 648. Sorry about that. And we're going to say no IP OSPF cost 648. There we go. So the 648 was already applied on these interfaces. We needed to remove that in order to make it look more attractive, a better hop, and there we go. So now we go to 332 and then to 221, which is router 2, and then out to the TFTP server. So the change, and again, the change has been made to direct the traffic over the faster link. However, the backup route still needs to be tested. So let's shut down the gig 020 interface on router 3. Let's go into int gig 020 and say shut. And now let's test to make sure that the traffic is going to take that serial interface connection. Easy enough to do here. And there we go. And it goes out to 10.1.1.2. All right, so now the final thing we're going to do here is on router 2, after I bring this interface up. The final thing we're going to do here on router 2 is we're going to take a look at some NAT considerations. So we'll say IPNAT, show IPNAT translations. There are none. Show IPNAT statistics. And you can see there's not much going on here. So we've got an empty translation table. And it didn't want us, it was asking us to ping. Okay, so we're good there. Show IPNAT stats. And I'm just making sure there's no testing they want us to do here. Okay, attempt a ping from router 3 to the outside. So from router 3 here, we're going to say ping 64, 100, 110. And let's see if we can get out. And it does not appear as if it's working. Let's take another swag at. There we go. Okay. So I guess we're still waiting for that interface, the fiber interface, to come back up. So now on router 2, if I was to say show IPNAT translations, there's all those ping packets we just sent out, show IPNAT statistics, right? So we've got our count is incrementing, total translations 10. And you can see it was back-to-back ping commands, 5 ping packets, so total translations 10. We've got dynamic, no static natting being done. This is dynamic NAT, and we can actually take a look at the config here to see if it's dynamic NAT with overload, which it is, right? So we're doing PAT, port address translation. All right, so set the serial 000 interface as an inside interface to translate the addresses. And hold on just one second here. Notice that the list is empty. Oh, when you attempt a ping from R1. So let's try that, because R1 is going to use the serial interface here, I'm assuming. So let's go ahead and say ping 64, 100, 110. And the ping works. And that's because... So that's from R1. The ping should now be successful. Oh, I should have left... Sorry, this should have been left down is what they're asking for here. Global config int gig, gigabit 020, shut. And now R1's traffic is going to try to go to router 2. It has to. So now when I ping, we're missing the IPNAT inside command here on this interface. And that's the problem. Now, it's going to be interesting to see if they give us 7 points for that or not, because that is kind of the last thing I think we need to do. So we'll get into global config, serial 000, IP, NAT, inside. And that's it. That gives us our 7 points. So now, when we bring this interface back up, no shut, excuse me, and we try to ping from router 1, it now works. It works because we went out this way, and actually, I apologize. Let's leave this shut down for a second here, and the ping should still work now that it's being forced out that serial interface into the router 2 serial 000 interface. It's working, and then if we say no shut, it's going to continue to work even when this interface comes up and the traffic is transiting this direction, right? All right, let's take a look here. And there we go. All right, well, that is going to conclude this activity on Packet Tracer 12.5.13, where we got to dive in and do some troubleshooting across a really nice enterprise network that really challenged the skills that we had. All right, so that's it. Thank you so much for watching, and I hope to see you in the next video.